Hi everyone, this is Rémi Lafache from Monera. In this video, I'm going to talk about the Egor optimizer, which is integrated in WhatsOpt. Egor stands for Efficient Global Optimization in Rust, and while the optimizer is available in Python, it is built on top of EgoBox, which is a Rust library dedicated to efficient global optimization. This is the paper, the reference paper of the library. I will give you the link in the notes. Um, and for now, I'm going to optimize the CLR problem. Obviously, the CLR problem is really easy and solved by gradients based optimizer. But when you don't have the gradients of your objective function and your objective function is expensive to compute, the Ego method is really interesting. So here I'm going to edit the configuration to select the Igor optimizer, and then I'm going to update the code. I've already pulled the implementation, so here I'm just updating to refresh the scripts, and I can run now the MDO as usual, using this time the Egor optimizer. So I interrupt here the process because Egor works with an iteration budget. So here by default it is 100 iterations, but here for the Stellar problem in 10 iteration is able to find the best result. So if we go back here at the beginning, we can see that we have started with 5 points, with design of experiment of 5 points. And then iteratively, the Ego method try to find the location and find the location of the optimum. So here, in the history, you can read this data like this. Um, Here we have the x value, then we have the z vector. Here the objective function value, and then the constraints here, the two last values of the first line. And then you can see that after the five first points, we can count 10 iteration here: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Here we get the best result from the method. So we can see here 0 for x, and then the z value, and the objective optimum of the stellar problem. We can see here that the constraints are expected to be negative at the end. The first one is slightly positive because by default we have tolerance here for the constraints. So everything is fine, and we get here the result. Um, I can show you on the GitHub repository of the EgoBox library that we have a tutorial notebook for Igor, and we can see here that we install typically like any other Python module, the EgoBox module, which contains the Igor optimizer. And here in the tutorial, we can see that we use Igor like any other optimizer in Python. So thank you for watching, and see you next time. Bye bye.